Okay, clearly I already highlighted all the key information. So the first part actually requires us to find the equation of the tangent, which you know by now. You need to find dy dx. But before you do that, please make sure you simplify the expression first. Okay, I found the gradient function. So basically, I need to substitute the value of x inside to find the gradient of the tangent. Okay, but I know that if I need to substitute a point inside, I don't have my x value. Remember, I can do my side working. When x is equal to 2, go and find the corresponding value of x by substituting back into the original equation. So as you can see, the coordinates that I have is definitely 2, half. So now I need to put it into the form y equal mx plus c. So remember to make use of your y equal mx plus c, substitute a point inside. So once we found the equation of the tangent, remember to indicate that's meant for the tangent. And that's for part 1. Okay, in part 2, you see something new. The tangent meets the x-axis at A. The tangent also meets the y-axis at B. This is basically intersection of the x-axis at A, intersection of the y-axis at B. Am I right? Okay, if I need to find intersection, I need to know the equation of the x-axis. So the equation of the x-axis is y equals 0. The equation of the y-axis is x equals 0. See how I'm going to do my working. So I don't want to confuse myself. So in part 2, this is usually what I'll do. Oh, x-axis, I know is y equals 0. And you know from the first part, the tangent line is equal to this. So I need to substitute y equal to 0 into the tangent line. Can you see that? I need to substitute y equal to 0, which is the x-axis, into the tangent line. Solving by simultaneous equation. Since y equals 0, let me solve for x. Okay, I didn't do anything special. Remember, referring back to the question. Oh, x-axis, the tangent will meet at A and intersect A. So I write down x-axis, y equals 0. I substitute the y equals 0 with the tangent line. So now you have to do something similar for the y-axis as well. So similarly for the y-axis, I need to find the coordinates of B. But I know that if it lies on the y-axis, x is equal to 0. So substitute into the tangent line as well. So I replace my x by 0. I'll get y is equal to 2. Write down the coordinates and this will be the one for B. We have found A, we have found B, but we are also told to find the midpoint. So use the midpoint formula, the average of the x coordinate and average of y coordinates. Okay, so after that, we have found the midpoint of AB. That will conclude the final solution for part 2. Take note, in part 3, we are told to explain whether the midpoint, okay, the midpoint we found in part 2, whether the midpoint will lie on this curve. So I'm going to show you exactly how to do this because you will see this kind of question both in E and A math. Okay, take note, the curve given is y equal to 4 over x cubed. But I need to know whether this particular midpoint lies on this particular curve. Very simple. Just substitute the value of x equal 1 and 1/3. Substitute inside. When x is equal to 1 and 1/3, which is the x coordinate of the midpoint, let's find the value. 1 and 1/3 cubed. Go and press your calculator. So take note, I managed to find the y value to be 27 over 16. But remember, the original value of the y coordinates is 1. So I must write down, oh, this is not equal to 1. Since this is not equal to 1, midpoint of AB doesn't lie on y equal 4 over x cubed. Okay, this is in sentence. But because they ask whether it lies on, don't give me a yes or no. So I write out in sentence. So my working is shown over here. Substitute the value of x inside to see whether you get the same value as y. If it's the same, it lies. If it's not the same, you conclude it's not equal to that value and conclude with a statement over here.